and welcome to Cambridge Chemistry channel with Sarwat Ahmed. Today I will be solving question paper 1-2 from summer 29701. For each questions there are 4 possible answers A, B, C, D, and choose the one you consider to be correct. Use of the data booklet may be appropriate for some questions in which carbon allotropes are all electrons localized. Localized mean fixed. Buckminster fullerenes is the simple molecule. Electrons are not localized, and Buckminster fullerenes, the structure is like this. In diamond, the structure is like this, tetrahedral, and all electrons are localized. So it is correct. Incorrect. Graphite, also it is hexagonal shape, and each carbon is surrounded by 3 other carbon atoms, and 1 electron for each carbon atom become delocalized. This is also incorrect. Graphene is also the structure is hexagonal, so this is also incorrect because electrons are delocalized. 1 electron of each carbon atom is delocalized, so this is incorrect. The best option is B. A copper ore contains 3% of copper carbonate CuCO3 by mass. Which mass of copper would be obtained from 1 ton of the ore? Which mass of copper would be obtained from 1 ton of the ore? 3% of copper carbonate. So this is 3% of copper carbonate. So for ore and copper carbonate, 100% ore contains 3 and 1000 kg X. So it will be X is equal to 3 kg. So it means ore contains 3 kg of copper carbonate. Now which mass of copper would be obtained from 1 ton of the ore? Copper Cu ratio CuCO3 3.5 30. Okay, we know that copper in copper carbonate 63.5 kg contain CuCO3. 63.5 plus carbon 12 and 16 multiplied by 3 is equal to 48. So this is equal to 123.5 kg. 63.5 kg of copper is present in 123.5 kg. So what would be the mass of copper in 30 kg of copper to carbonate? Ratio x, do cross multiply, and this is equal to 15.42. So 15.4 kg is the correct answer. The catalyzed formation of ammonia by Haber process can be represented by the equation shown. N2 plus 3H2 to form ammonia. This is exothermic reaction, which change in conditions will increase both the rate of formation and the equilibrium yield of ammonia. We know in the reversible reaction, decrease in temperature, which change in condition will increase both the rate formation and equilibrium yield of ammonia. This is exothermic reaction. Decrease in temperature will favor the forwards reaction, but reaction is slow at this temperature. Increase in temperature, it is not correct. Increase in temperature will favor the backward, will favor the backward, will favor the endothermic reaction, and reaction will shift backward, so less yield is produced. This is also incorrect. Increase in the pressure will favor the forward side because there are increasing pressure. By increasing pressure, reaction will shift the side with less number of moles. So on the product side 2 moles of ammonia, and on the reactant side it is 4 moles of ammonia. So it will move forward and as well as increase the yield of ammonia. So this is correct. Increase in the surface area of catalyst. Catalyst does not affect the yield of the product. So this is also incorrect. Solid sulfur consists of S8 molecules. Which equation represents the standard enthalpy of atomization of sulfur? Enthalpy change of atomization when 1 mole of gaseous atom is formed from its element under standard conditions in their standard states. So Sulfur exists in solid state at room temperature and pressure, so it must be correct. Solid to gaseous atom. Now let's check on other options as well. This is gas, this is gas. Sulfur exists in solid state, so at RTP, room temperature and pressure, standard condition is solid, so this is incorrect. Acid, solid to gas, so this is 8s, not 8s. Atomization is 1 mole of gaseous atom is formed, so these are 8 moles, so this is also incorrect. Acid gaseous to form 8s gas, so this is incorrect. No, this is also incorrect, this is also incorrect, so the option A is correct option. In this question you should use question number 5. In this question you should use changes in oxidation numbers to balance a chemical equation. The following reaction occurs when MnO2 is warmed with dilute sulfuric acid. What is the ratio of CND in the correctly balanced equation? MnO2 in MnO2 the oxidation state is 2MnO2. This is Mn plus 2 minus 2 is equal to 0. Mn is equal to plus 4. The oxidation state of manganese in manganese 4 oxide is plus 4. Here plus 2. In manganate ion is equal to minus 1. Mn plus 4 minus 2 is equal to minus 1. Mn is equal to minus 1 plus 8. So this is equal to plus 7. So MnO4 carrying plus 7. So this is going to reduced with change plus 2, and this is going to oxidized. This is reduced and this is oxidized, and the change is over here minus 2, change is minus 2, and over here change is plus 3. Plus 3. So to balance this equation, plus 3 and this is change is plus 3 and this change is plus 2. So this is going plus 3, so cross multiply, so this is going with 2. So what is the ratio of C and D? Plus 2. So along with 3 it is Mn2 plus 3Mn2 plus, this is into plus 3, and this chain is going with into plus 2. So the ratio is 3:2. In this question you should assume air contains 21% oxygen. What is the minimum volume of air required to ensure complete combustion of 10 centimeter cube of butane gas under room conditions? Butane gas under room conditions. 10 centimeter cube of butane C4H10 plus O2 to form CO2 plus water. So balance this reaction 4 CO2 and 5 water, and 4 to the 8 and 5 13, 6.5. So if 10 centimeter cube of C4H10, the volume of oxygen is 6.5 into 10 centimeter cube, because if 1 mole of C4H10 is equal to 10 centimeter cube, so what would be the volume of oxygen? So volume 6.5 mole of oxygen is equal to X. So this is equal to 65 centimeter cube of oxygen. Now in this equation you should assume air contains 21% oxygen. So we know that air oxygen 100% containing in 121% oxygen is 21% oxygen is present, so 65 ratio X. So what would be the air if 65 centimeter cube of oxygen react with butane? So do cross multiply and we get 310. So this is the correct option. When aqueous bromine is shaken with cyclohexene and allowed to stand 2 layers from the top, cyclohexene layer is colored and the bottom aqueous layer is almost colorless. What is most likely explanation for this observation? What is the most likely explanation for this observation? Bromine is reduced to bromide ions in the bottom layer. Bromine is reduced to bromide ions in the bottom layer. So bromine is not reduced to bromide ions, cannot reduced to bromide ions. So this is incorrect. Bromine molecules are non-polar. This must be correct because same poles are there, so bromine is non-polar. So this must be correct. Bromine reacts with water but cannot react with cyclohexene. Bromine cannot react with water, cannot react with cyclohexene. Bromine cannot react with water but can react with does not react with cyclohexene. So this is also incorrect because cyclohexene is cyclic structure. The cyclic structure does not react with bromine. The product of the reaction between bromine and cyclohexene is colors. So this is also incorrect. So correct option is B. Bromine molecules are non-polar. In which change are only temporary dipole-induced dipole forces overcome? C2H5OH is not in ethanol. permanent dipole forces are present because OH is there, electronegative element is there. Dipole forces, water also hydrogen bond, H bond is present. So this is also incorrect. Oxygen solid to oxygen liquid. So this must be correct because oxygen molecule has a dipole induced dipole forces. So this must be correct. C4H10, C4H10, only temporary, liquid to solid. Again, non-polar. Induced dipole forces are present in oxygen, so this must be in van der Waals forces. So this is incorrect. The complete combustion of 2 moles of an alkane produces 400 dm cube of carbon dioxide measured at 301 Kelvin and 1 into 10 raised to 5 Pascal. Carbon dioxide can be assumed to behave as an ideal gas under these conditions. What is the formula of alkane? What is the formula of alkane? CXHY plus oxygen to form carbon dioxide and water. PV is equal to nRT. And N is equal to PV over RT. N is equal to pressure 1 into 10 raised to 5 from data booklet. Volume is 400 dm cube. So 400 converted into dm cube into meter cube. So divided by 1000 divided by 8.31 gas constant and temperature is 301 Kelvin. So N is equal to 16 moles. So number of moles are 16. So and this is alkanes. If this is carbon dioxide can be assumed behave as an ideal gas under this, what is the formula of alkane? So if carbon dioxide 16 moles of carbon dioxide are there, so the carbon must be C8. So alkane is C8 H18. So this is C8 H18. So to balance this reaction, and this is 16 carbon dioxide and 2 18s are 36, 18 H2 and 16 oxygen, 16 to the 32 and 32 18. So this must be 25 oxygen. So A option is correct. In which reaction does an element undergoes the largest change in oxidation number? Cl2 0 to OCl minus this is -1 and H2 +1 and -2 oxygen OH minus -2 plus X is equal to -1. Plus 2, this is equal to +1 oxygen is carrying +1 and oxygen carrying -1. X plus X minus 1 is equal to -1. X is equal to -1 plus 1 cancel. Over here 0 plus 5 and -1. Cr2 7 plus 6 and plus 3 plus 2 or plus 3 plus 2 plus 3 MnO4 plus 7 plus 4 minus, this is -2, this is plus 6 and this is plus 7. So the largest change in oxidation number is 0 to +5. Change is +2 and +1. Change in oxidation +3. So this is incorrect, this is incorrect. So largest change is 0 to +5. So this is correct. PCl5 decomposes as shown. PCl5 to form PCl3 plus Cl2. 1 mole of PCl5, 1 mole of PCl3 and 1 mole of Cl2 are placed in a container of volume 1 dm cube and allowed to reach equilibrium. At this temperature, the equilibrium mixture contains 1.8 moles of PCl3. PCl5, PCl3 plus Cl2. 1 mole, 1 mole and 1 mole. At equilibrium 1.8 moles. It means change is 0.8. Over here 0.8. So this is 1.8, this is 1.8. And if change is 0.8, then 1 minus 0.8 is equal to 0.2. So the change 0.2, and Kc, we know that product or reactants PCl3 Cl2 over reactant PCl5, 1.8 to 1.8, 1 divided by 0.21. So the answer is 16.2. The D option is correct. Question number 12. The fifth to eighth ionization energies of four elements in period 3 of the periodic table are shown. Which row refers to the chlorine? Chlorine is present in group 7. So there are 7 electrons in the valence shell. So there should be greater difference between 7th and 8th electron. 21, 2025, 900. So this is incorrect. There is little difference. There should be big gap between these two values, 7th and 8th. B6, this is also incorrect. C65, 6540, 9330, 11,000 and 33. There is a big gap, so this must be correct. 7, 12,000 and 13,000. This is also not a big difference, so this is also incorrect. So C option is correct. Magnesium nitrate decomposes when heated to give a white solid and a mixture of gases. One of the gases released is an oxide of nitrogen. X 7.4 gram of anhydrous magnesium nitrate is heated until no further reaction takes place. Let's write down the chemical equation. Magnesium nitrate NO3 decomposed to form magnesium oxide, white solid magnesium oxide plus mixture of gases nitrogen dioxide plus oxygen gas. So to balance this equation, so this is the chemical reaction. 7.4 anhydrous magnesium nitrate. What mass of X is produced? 7.4, 24 mR of magnesium nitrate, 24 plus 28 plus 96, 16 into 3 into 2, 3 to the 6, 16 into 6. So this is equal to, let's calculate, 24 plus 28 plus 16 into 6 is equal to 148. So this is equal to 148. 7.4 gram. So calculate the mole of anhydrous magnesium nitrate. 7.4 divided by 148. So this is equal to 0.05 mole ratio, 1:2, 0.05 ratio X is equal to 0.1. x is equal to 0.1, so mass is equal to mole into mr. Mole is 0.1, mr is 46, so this is equal to 4.6. so D option is correct.